Here in ESF, I'm working on processing the drone data for tree inventory, or in other words, for tree detection and parameter estimation using AI machine learning methods. So what I'm doing here, we capture drone data, including lidar and multispectral data, and then using AI machine learning, which we developed some methods recently, detect the individual tree. And then after we detect in each individual tree, we estimate and extracted some parameters of the tree, including tree height, crown diameters, volume, species, biomass, and this kind of parameters. Well, looking at a program that ESF has it here, which is combine drone or technology with the environmental issues that we have, and getting to know Bahram as my advisor, make me wanted to come to the ESF and pursue my PhD here, because not only I can use the advanced technology like drone that we have here, but also I can use like Bahram's advisions as I'm pursuing my PhD. ESF for my specific major as a photogrammetry and remote sensing engineer offered me a very good access to the drone and the data that I would need to capture by myself. We have a drone here which include and equipped it with 3 different sensors, including lidar, multispectral, and high spectral, which with these 3 sensors we can almost cover any type of application in remote sensing using drone, which is actually very helpful, and I haven't seen that in a lot of school, like to have all of these sensor and equipments together. Usually when it comes to especially remote sensing, you need to request to some organization and then ask them to send you data, or try to get some permission for data. But having an access to such good equipment and technology, I would say it's a really big advantage to me, especially for my work and what I'm doing here. The method that we developed recently called TreeNet, that's a method, it's based on the AI and using the point cloud. It's a drone point cloud. It detects the individual tree automatically and extract the parameter. So for example, comparing our method or our new AI machine learning with the traditional, well, we can see there are some trees that has not been detected using a traditional method, but we will be able to detect all of them as individual tree. After we detect all this in single tree, which this area is in hybrid area, and then we will be able to detect the individual trees point cloud, and then using the tree point cloud we extract the height, volume, mesh, and other parameters such as the biomass estimation. We implemented this method for the city of Fayetteville, and I'm excited to implement it to other towns and cities. We're actually planning to make it a software so everyone can use it. Whoever doesn't have a drone knowledge, they can just easily import the input and then see the output of the methods, or see the output of the individual trees and height and location, count the number tree, all of the things, all of this parameter. There is a couple of stuff I would say that always help me whenever I'm dealing with a problem, or I'm working so hard sometimes. The first thing I would say is my social life out of school. Right? I play volleyball, and that helps me a lot to relieve and refresh my mind so I can get back to work and do stuff. And the community that I know through volleyball helped me to find a new way of my problem, the solution for my problem. That's one of the things that really helps me. The other thing is I'm keeping to reading the literature and try to actually refresh my knowledge, because every day a new method coming up, and try to inspire from those methods and implement it on my own problem or own method that I'm developing at. So by integrating a new method and reading constantly the literature, I try to solve the problem that I'm dealing, or try to find a better way always. It wasn't always good, for sure. So many times we have up and down, but all of this up and down makes me to be where I am right now.